Space, the final frontier. Hey kids, for today we're going to talk about propulsion. And propulsion comes in many ways and many things, and scientists have really evolved in the methods of propulsion. We're not going to go way back, but we're going to go back to some things and then bring it up to space. Kids, you've done things that you probably don't even realize you've done that are matters of propulsion. Every day you walk, every day you talk, you're doing things with your body and your mind that you don't realize that you're doing. Riding a bike, pushing a cart, all these things are methods of propulsion. And lucky we have something on our planet called gravity. And then there's inertia, and that's when you're actually using the force to push things and make things move. Gravity and inertia plays a big part in propulsion. Basic propulsion starts with some kind of chemical balance that is already around us. Everything around us has things to do with propulsion, believe it or not. The water dropping in a rainstorm is something bringing it down to earth, which is called gravity. Gravity works in with other substances in our world that makes things move and float and fly and do different things. I'm going to show you a little experiment that I put together using a martial arts weapon, believe it or not, but just to show that there is inertia in everything that you put motion to. All right, let's do this one more time. It all started with E equals mc squared. This is the basics of what Einstein and the scientists from way back experimented with gravity, experimented with velocity, experimented with propulsion. When propulsion elements were first starting, using the muscles of the body, the muscles of the force of action. Your arms have muscles. That's when you can pull stuff. You actually making a reaction. Because a chair, if you put the chair sits here, it won't move by itself. If you put your power to it, though, if you put inertia to it, you can move it. It's the same way as in something like this. Simple demonstration. Swivel chain nunchakus. Ball bearing system inside. They spin on a ball bearing axis, just like that. You can allow force to use them when you're defending yourself. There's power behind your arms. Other than that, it would just sit there and do nothing. So the whole point is that you have to put power, you have to put some kind of force behind your actions. E equals mc squared. It's not rocket science, but it was the beginnings of rocket science, which gets us a whole nother universe of stuff that's out of this world. And I can't do that with the nunchucks in here because I'm in a classroom and they may think I'm going crazy. So I'm out.
X minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Affirmative.
Hi, Captain Kirk. We've got our space part of the program out now, haven't we? But the engines are about to blow. But maybe not, because we got a nice little kitty thing here. It shows that you can do things even on your own science way.
Today we are going to build bottle rockets. Kids, ask a grown-up to help you with this experiment, because there's gas under pressure. There's a scientist long ago named Isaac Newton. Rockets move because of Newton's third law of motion. Newton's third law of motion states that for every action there's an equal and opposite reaction. For this experiment, you'll need some vinegar, a bottle with a sports lid like this, some baking soda, and some aluminum, and some foil. When baking soda and vinegar react, it creates carbon dioxide. This is called a gas evolution reaction. Baking soda is a carbonate, and vinegar is an acid. Acid plus carbonate makes salt water and carbon dioxide. Carbon dioxide is a gas. Salt. When the pressure builds inside, the cap will pop open and the gas will shoot out. You see how this lid pops? When the carbon dioxide shoots out, the bottle has an equal and opposite reaction. We move the opposite direction. Here's my friend Roddy, the reacting rocket. He's going to show you how Newton's third law of motion works. The pressure builds up inside the bottle and shoots out the back of the rocket. Stop, Riley. Pause. When the gas shoots downward, that's an action. The reaction is when Riley shoots upward. This is Newton's third law of motion in action. Okay, Riley, you can go again. Fold the foil into a little cup. I just made a little boat for the baking soda. Pour some vinegar into your bottle. Now take the baking soda and put it in your little boat. Cover the boat on top, so the baking soda only escapes when you shake the bottle. You leave a little opening in the foil and carefully drop it in. Cover the bottle as tightly as you can. You should probably go outside for this next part. Put on your safety glasses and go outside. When we shake the bottle, the baking soda will escape and react with the vinegar. 3, 2, 1, blast off! Look at these awesome bottle rockets. Look how far that one went. That one sprayed right at the camera. Isn't this cool? We even tried strapping it to other stuff. See our rocket truck? If you like this video, then make sure to hit the thumbs up button down below and subscribe to my channel so you can see all my fun videos. And remember, kids, science is fun. Like this video.
All right, kiddies, that was fun. That's propulsion. That's all.